want to find a power series solution to a differential equation. The differential equation is given by this equation. Now, if we're looking for a power series solution, that means our solution is going to be in the form y of t equal to c naught plus c1t plus c2t squared plus c3t cubed. Okay, so that's going to be a power series. That's just a general power series. But remember, the Maclaurin series, the Taylor series, has these coefficients. The c sub k's will be the kth order derivative evaluated at 0 over the k factorial. So my goal is going to be to find these coefficients. Okay? Once I get the kth order derivative at 0, then I'll know what that c sub k will end up being. Okay, the first thing I want to use is the fact that y of 0 is equal to 6. Okay? That means if I take this function and just evaluate it at 0, y of 0 will be equal to 6. But y of 0 will also be c naught plus c1 times 0 plus c2 times 0 squared. And you can see all the other terms are going to be 0. Y naught is just 6. And so that means our c naught will be 6. Okay? Now, the next thing I want to look at is this differential equation up here. Now, if I know that c naught is equal to 6, I know that c naught is also let's see, c sub 0, that's going to be just y of 0 over k factorial. And let's see, my k in this case is 0, so it's just c sub 0 factorial, which is just y of 0. Okay? Okay, so now, to find the other derivatives, I'm going to use the fact that y prime of t is equal to y of t plus 2. Well, specifically then, that means that y prime of 0 will be y of 0 plus 2. But y of 0 was 6, so that means y prime of 0 is going to be equal to 8. Okay, now y prime of 0 tells me that the c sub k then is going to be equal to 8 over k factorial. And now this is just for the first derivative. So this is just for c1. c1 will be equal to the first order derivative at 0 over 0 factorial, or 1 factorial. And the first order derivative at 0 is going to be 8. So 8 is just the c sub 1. Okay, now what I'm also going to get from this is that the second order derivative, I'm just going to take the derivative of both sides. The derivative of the left side is second derivative. The derivative of the right side is y prime of t plus 0. That tells me that the second derivative is going to have the same value as the first derivative at any value. So that means y double prime of 0 will be the same thing as y prime of 0, which we know y prime of 0 was just equal to 8. So that means y double prime of 0 is also 8. Okay, so now that means that my c2 is going to be 8 over 2 factorial. And you can see that it's just going to follow for every derivative after that. The third order derivative at t will be the same as the second order derivative by taking the derivative of both sides. So that tells me then that y triple prime of 0 is the same as y double prime of 0, which is 8. So that means that c3 is going to be the 8 over the 3 factorial. Okay, so now I've got those coefficients that I needed. So now writing my Taylor series, power series representation. Okay, using what I have at the top there. I have then that y of t is c sub 0 which we know was equal to 6, right here, plus C1 is 8 over 1 factorial times t. C2 is 8 over 2 factorial times t squared. C3 is 8 over 3 factorial times t cubed, and so on. Now, if you recognize this, it looks a whole lot like the e to the x. Remember, e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial. Okay? The power of the variable and the power, the factorial match. So the only difference is that 8 that's at the front. And what I want to do here is I'm going to just add and subtract a term just to make this come out the way, a really nice way. I'm going to change this 6, and I'm going to rewrite 6 as -2 plus 8. And then I'm going to just rewrite everything else that's there. 8 over 1 factorial t plus 8 over 2 factorial t squared plus 8 over 3 factorial t cubed, and so on. And now I'm going to notice that I have 8's in common with everything, and that was the only reason for putting that, writing that 6 as the -2 plus the 8, is now I can take an 8 out of all those other terms. I have -2 plus 8 times 1 plus t over 1 factorial plus t squared over 2 factorial plus t cubed over 3 factorial plus, and that should look familiar to you. It is this Maclaurin series for e to the t. So my function, y of t then, is -2 plus 8 times e to the t. So let's see, we had the rule that y prime was equal to y plus 2. Okay? So now this is my y. If I took the y and added 2 to it, I should get the same thing as the derivative. And the derivative of this side is just 8e to the t. So this does check out. And if you check the initial condition, put it in 0 for the t, I do get 6 for my y sub 0. So this would be the solution to the differential equation in power series form. And now, you know, this is actually the power series solution, but we solved it using the power series, and then you can see here that it is also a familiar form. So if they wanted the power series solution, then you can leave it right here, or this form, any of those is fine.